Alright, in this video we're going to introduce the DEWNC, our last little section of the work and energy unit. And this is how we can quantify work done by non-conservative forces, which will change the total mechanical energy of a system. So let's start with some things we already know. And we already learned that the work done by forces acting on an object will cause a change in the kinetic energy of that object. So this is our EWOC. So if we want to know the change in K of an object, all we need to do is figure out all the different forces that are doing work and sum that together, and that'll tell us our delta K. We also defined mechanical energy. And we said these are special types of energies associated with conservative forces. So the total mechanical energy of a system or an object is its kinetic plus its spring potential plus its gravitational potential. And we've seen that if only under the influence of conservative forces like spring force and gravity, that this delta E is 0. Well, all delta E is a sum of the change in kinetic plus the change in gravitational potential plus the change in spring energy. And we also saw that this change in the gravitational potential was inversely related to the work done by gravity. So as gravity did negative work on an object, it corresponded to a gain, an increase in potential gravitational energy. And the same thing was true for spring force. When the spring force does negative work on a mass spring system, then it gains spring potential energy. So this is something we're going to use now along with EWOC to come up with an expression for how we can solve problems when we have work done by non-conservative forces. Alright, so bear with me in this derivation. So let's start with EWOC. And instead of just saying the net force, let's just put in, or the network, sorry, let's put in the work done by a bunch of different forces. Let's say there's an applied force doing work, a frictional force doing work, a normal force doing work, and there's a gravity force doing work, a spring force doing work, a bunch of different types of forces that we can come up with doing work on an object or a system. Now, we can separate these. These are what we call our non-conservative forces, and these are what we call our conservative forces. So let's get our non-conservative forces on one side. Sorry, let me move that over a minute. And let's subtract the work done by the conservative forces to the other side. So I'm going to get the work done by the applied force plus friction plus the normal force equals delta K minus the work done by gravity minus the work done by the spring force. Well, what are these non-conservative forces? If I add up all that work, this is just the work done by non-conservative forces. So when we say the work NC, this is the total amount of work done by non-conservative forces. That's our WNC. And then we have delta K minus WG, the work done by gravity, minus WS, the work done by the spring force. But here we can use these correlations to say that, well, when gravity does negative work and when spring force does negative work, it corresponds to a positive increase in the corresponding potential energies. Right? And what do I have over here? Oh, this is just the total change in mechanical energy of a system. So simplifying this, I get when the total energy of a system changes, a conservative mechanical system with the mechanical forms of energy, delta K, delta UG, and delta US. If any of these are not 0, it's because some non-conservative force must have done work on the system. So another way of stating this is to change the total mechanical energy, E, of a system. There must be work done on the system by non-conservative forces. So that's how we change the mechanical energy of a system. Sorry, I'm getting off the screen there. We do work by friction or by applied force or by a normal force, and that will change the total mechanical energy of a system. And there we go. The delta E equals WNC. How do we get DEWNC out of this? So the delta E is our D, and the WNC is our WONC. So there you go. The DEWNC.